Hi again. I'm just going to finish up here the last four or so slides that we have from yesterday's, that's Monday's lecture, and I just about got to the point where we were going to look at patterns of inheritance really through human populations and how you track those using pedigrees. So with a few exceptions, Mendel's observations from the first and second law have been found to be applicable to patterns of inheritance in humans, and we can track from generation to generation patterns of inheritance using pedigree analysis. To start with, we're just going to consider autosomal patterns of inheritance, and later, probably in chapter 3, we'll get to looking at sex-linked patterns of inheritance traced through pedigree analysis. So the pedigrees allow the tracking of traits from generation to generation in families, and that lets us look at the transmission of things like diseases or the probabilities that carriers will be found in certain generations and certain individuals in generations. So there's a standard notation that's used in the pedigrees that we'll look at. You'll become familiar with these over time and with the notations, but for now I'd recommend you just make a cheat sheet and pop it in front of a binder or on a note card or something and have that handy to reference. And of course, with a notebook final, you can always look this up if you need to, but the quicker you can solve these kinds of problems without reference to a book, the faster you'll move through an exam and be able to spend more time on more difficult problems. So when we look at characteristics when we look at the notations in pedigrees, and we look at patterns of inheritance in respect to autosomal dominant characteristics, we see that there are 6 characteristics of an autosomal dominant characteristics that are transmitted through a pedigree. First of all, the individuals with disease have an affected parent. For example, in this individual here, generation 2, individual 2, so that's Roman numerals 2, 1, 1, and individual 2, that individual has an affected parent. So with an autosomal dominant character that's passed from generation to generation, if you've got an affected parent, you'll see an affected child. Males and females are affected in equal numbers, and we'll compare that with sex linkage, where that's not true. Either sex of the parent can transmit the allele. So here we see this female transmitting the allele in generation 1, and here we see a male transmitting the generation in generation 2. If you have a homozygous recessive by a dash cross, that's either a homozygous dominant or a heterozygous individual, you'll find that half of the offspring are affected. And so we can see that here in this cross between individuals 5 and 6 in generation 2. Individual 5 is homozygous recessive. They must be because they have the condition. And individual 6, we just know that individual has a heterozygous condition, and is what you see is 1, 2, 3, 4. We've got 1, 2, 3 out of 1, 2, 3, 4, 5. Nearly half, about half of the individuals. You also see that unaffected parents have unaffected offspring. So in these individuals here, neither of these parents have the condition, and so none of their children here, individuals 7, 8, and 9 in generation 3, would have the condition either. And lastly, heterozygotes that cross can produce homozygous recessive individuals that are who are unaffected by the disorder. Remember, this is autosomal dominant, so a homozygous recessive would not be affected by the disorder. Now we can compare that pattern of inheritance with what we see with autosomal recessive. And in these pedigrees, we see that individuals with the disease can be born to unaffected parents. So if we do a heterozygous cross, we would have the possibility of a homozygous recessive individual who would then have the disease, even though the parents did not. So that's possible. And you'll see that, for example, these 2 parents here are unaffected, but they've got 2 children, number 6 in generation 4 and number 10 in generation 4, who do have the disease. That would be indicative that these 2 parents are homozygous, are heterozygous, sorry. Secondly, if one parent has the disorder, the risk of the offspring having it depends on the genotype of the other parent. Okay, so you think about that. If one parent has a disorder, the risk of offspring having the disorder depends on the genotype of the other. Okay, so if you've got a homozygous recessive parent that has the disorder, whether the other parent is homozygous dominant or heterozygous will determine whether the offspring can have the disorder. If both parents have the disorder, all offspring will have it. For example, if we look at these two individuals here, individuals 5 and 6 in generation 4, they both have the disorder. They must be homozygous recessive. All of their offspring must have the disorder. If you think about it, that makes sense. Each of the parents, 5 and 6, will donate a recessive allele, and that will lead to a diploid with 2 recessive alleles and subsequently also have the disorder. As in autosomal dominant patterns of inheritance in these pedigrees, we see that the sex ratio of the affected offspring is equal. So there's no disproportionate representation in males or females here. Obviously, that's because we're talking about autosomal inheritance here. You may see that the disorder may skip generation, it may skip 2 generations, so you want to look for that too when you're looking at a pedigree analysis. And lastly, if the disease is rare, then unaffected parents of affected children are more likely to be related than not. Okay, and that's just an artifact, or that's just a consequence of inbreeding. So those are the points to consider when you're looking at pedigrees and trying to determine whether you're looking at autosomal dominant or autosomal recessive. Easy little problems to put in exams. You just make up a pedigree and then you've got to determine whether the pedigree is representative of a disorder or condition that is inherited autosomally recessive or autosomally dominant. And lastly, in your handout 2, there is a question 6, and I have now posted all the keys for handout 1 and handout 2, along with handout 1 and handout 2 themselves, so you can rework those problems. Okay, that is it, and I will see you tomorrow, Wednesday, when we'll get back to chapter 3.